Welcome to the White Academy. So today we'll be looking at some aspects in organic chemistry. Now, as you know that when you talk about organic chemistry, so that's an aspect of chemistry, devoted to the chemistry of carbon. Okay, but not simple carbon, molecule as it were now, carbon compounds now. So we deal with, at least carbon atoms, nothing less than 2, 3 and above, you understand? So compounds of carbon like CO, you understand? Nitriles, you understand? No, so that's a cyano and all the like. So they are best dealt with in inorganic chemistry. So most especially, as coordination, maybe as ligands. So whether in coordination chemistry or in organometallic chemistry, as the case may be. So, but then today we are just interested in an aspect we call Aldol reaction. All right, or what we can call, Aldol reaction or Aldol condensation. All right, so I want to assume actually you're already familiar with what's it called? You're already familiar with different kind of mechanisms, involved, such as heterolytic, homolytic mechanism, things like precyclic mechanism and so on. To understand, so very other reaction like other reactions, talk about Merkel addition, Van gel, cleansing, condensation, packing condensation, benzoin condensation, the format scale. These are different various kind of reaction, which actually have been proven worthwhile, in organic chemistry and organic synthesis. So now, what's another condensation? Specifically, it has to do with reaction between, 2 moles, of an aldehyde, or ketone. Are you getting my point now? What am I saying? Actually, when I put 2 moles, of an aldehyde together or a ketone together, I can get an aldol product. You understand? So now, how do we come about such? Essentially, this chemistry has to do with so let's begin by this. You recall that when we have this RC double bond OH, so this is an aldehyde, then R, C double bond R. You understand? So basically what is common to both of them actually is this carbonyl, functional group. And of course, as you are aware that this is not the only carbonyl compounds that we have. We have other things like acid anhydrides, esters, you understand, carboxylic acids, acid halides, these are also various forms of a carbonyl, compounds. Is that okay? But this particular reaction is actually essentially, or let me say devoted, has been studied for aldehydes and ketones. All right? Now, why is it so important? First of all, I will ask you to remember that actually this is a kind of sp2 hybridization that is taking place here. Of course, remember the bond angle, that's 120 degrees, for them now. Okay? You agree with me, actually, this particular molecule is planar. You understand? And one of the things you have studied, in the chemistry of aldehydes and ketone, is that this highly electronegative atom oxygen here, by inductive effect, and as a matter of fact, this double bond drawing electron more toward itself. Are you getting my point now? Leaving this carbon atom here partially positive. You have to note that, okay? So that is one essential, carbonyl chemistry that you must not forget. And additionally, again, looking at this plane, when any, of course, you agree with me that if this is partially positive, all right, as this one partially negative, okay, it's leaving room for what we call a kind of nucleophilic attack, all right, on this carbon atom right here. So any nucleophile can come, and when it is coming, it's either attacking above or below the plane. Are you getting my point now? Just view this molecule as my palm like this. Are you getting my point now? And then with your R and R group, pointing in this direction. Is that okay? So when a nucleophile is coming, of course, it will not approach along this anarchy substituent or uride substituent as the case may be. Is that okay? It's either coming above or below the plane. Is that okay? But of course, that is not the most important thing today. Is that okay? Now, another thing again is you must understand, and which is basically for this Aldol condensation, is this acidic beta-hydrogen. Now, let's take a very simple molecule. Look at, ethanamide. Yes. So when you look at acetaldehyde, rather. So when you have acetaldehyde, I get my point now. I'm talking about ethanol right now. So when you have acetaldehyde, you have CH3, C, and then you have this. Okay, good. And of course, you know the difference between ketone and aldehyde. This one has a carbonyl hydrogen, while this one, the hydrogen has been substituted with an alkyl group. So take note of that. But now listen to this. Essentially, for any molecule or any compounds of an aldehyde or ketone to undergo an Aldol condensation, there's of a necessity of what? An alpha hydrogen. This is very important. Is that okay? Now let's go. Now, having explained the chemistry of the carbonyl, which I mentioned earlier, go back right in here. Now, this is partially negative, partially positive, as it were. And as a result of electron withdrawing, okay, a kind of negative inductive effect, the electron cloud being pulled towards oxygen, there's going to be a kind of chain effect, on this carbon atom right here. Are you with me? So if what am I saying in essence is that I have C, H, 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 this, then I have my carbonyl group. Are you getting my point? So looking at the direction of the arrow, as a result of what? A kind of a negative inductive effect, electron withdrawing atom there, which is oxygen because of its highly electronegative. Okay, then the electron density moves in this direction. So leaving any of these identical protons here or hydrogen here, susceptible to any, nucleophile. Is that okay? That is, a base can actually abstract this proton. Take note of that word, abstraction, of hydrogen. This is very important. I hope you are taking note of this mechanism. It's very important. Is that okay? So the electron cloud, spending more time with oxygen, having a consequence effect on this alpha carbon. This is alpha carbon. So if this is alpha carbon, that will be alpha hydrogen. Is that okay? 3 of them identical in this environment. So it means that actually your base, which is your nucleophile, okay, can readily attack. So in other words, okay, the acidity of these 3 protons here, increased as a result of what? Of this negative inductive effect. So that's actually the basis of Aldol condensation. So before you can have Aldol condensation, at least an aldehyde, must have at least, there must be a presence of at least alpha hydrogen, at least one, for that reaction to take place. So you need to understand that. So just look at, let's look at a typical example. Now look at this. Let's take this reaction. Okay, for instance, we have CH3. Okay, C, HO. This is an aldehyde. Is that okay? All right. Then, so, and when that one forms, it's going to give you a kind of beta hydroxy, hydroxy aldehyde or beta hydroxy ketone. Okay, that's going to be the product. Now, let's look at that. So, this one molecule, this one mole, this another mole. Is that okay? But of course, this reaction actually will take place. Maybe you have something like sodium methoxide, NaOH, or maybe something like you have something like NaOH. So at least a base. Is that okay? It's also possible in an acid, but we soon find that actually the degradation of this actually will give you a kind of alpha beta unsaturated product, which we'll soon find out. Is that all right? So now, how do we come about this? Let's check the mechanism. Watch it. I have C, H3. Is that okay? Double bond, then H. Are you there with me? Now, in this sense, if actually I'm to, bring all of this out, the very first thing is what? So don't forget, Actually, your base, which is your OH here, actually is acting as what? As just a catalyst. So it must be in basic medium. It could be in acidic medium like I've mentioned. Is that okay? It's only that actually it's just going to be a kind of protonation. Alright? But then let's move. Now, in this case, now watch it. Your base is here. Okay? Don't forget, because of the chemistry I've demonstrated earlier, this being acidic, this guy, you always draw your arrow from electron to the electron deficient. Is that okay? So when that happens, then what will result is this. You have your CH2, all right, which is going to be a carbanion. Are you getting my point now? All right? And then you have a C double bond O, and then you have H. So look at this now. This has become, a nucleophile itself. Is that okay? So now, of course, this guy is unstable. Then it's going to attack the second molecule of aldehyde that you have here. Are you with me? So then it follows that we have CH3, C, double bond O. Then you have your H. This is partial positive, partial negative. So therefore, this is going to attack this. When it attacks your carbonyl carbon, then of course it will induce, the migration of the pi electrons, to oxygen, and then the result is this. We have something like, we have CHO. Are you with me now? Then I have CH2. Are you there? Then bonded to what? C. All right. But then O minus, because now negatively charged, carefully carrying the positive negative charge. Then you have your H, and then you have your CH3. Is that okay? So if you do that so well, and I extend it now, the thing is this. Don't forget, in the first place, what do you have? You have your it was starting your base. That's your OH now. That's your B minor. That one was forming BH for you. Do you remember that? Okay. So now the result that now happen is that as a result, this guy picks on this, so that actually you can regenerate your what? Your base that you started with. Are you getting the point? And then the end result is a beta-hydroxy, carbonyl product that you have. So then we have this, double bond. Okay, let's do it this way so that it will make sense to you. So we have this. So we have CH2, we have C. Is that okay? Then we have OH. Again, so alpha beta. This is a beta hydroxy, then H, and then CH3. Is that all right? Okay, so that's the mechanism. So I hope that is taken. All right. So the same principle also follows for ketone. In fact, as a matter of fact, this one is going to have two different environments, of your alpha hydrogen. Is that okay? Take for instance now, if you look at acetone, for instance. So acetone is CH3. All right, C double bond O, CH3. Is that okay? So either of these 6 hydrogen is susceptible to what? To a nucleophilic attack. Is that okay? So which we draw electrons from the, as a cast, and then you can have 2 of them. But then note, okay, you should ask me a question that, okay, what about a case whereby you have a ketone and aldehyde, together? Actually, this one's going to give you a generation of 4 different possible products. So you have to take note of that. Is that okay? And then note, we emphasize the issue of what? Alpha hydrogen. That is very important. Things like benzaldehyde, doesn't have alpha hydrogen. So therefore, it will not undergo Aldol condensation. So such a case can be considered under cleansing condensation. Is that all right? I hope you have understood. So on subsequent video, so we can look at cleansing condensation, benzoin condensation, and several other ones. So I hope that is taken.